Hi, here I am going to discuss all the important topics of power system. Those are required for attempting gate examination as well as IAS, that is ESC examination as well. The important topics that I am going to discuss here are transmission concepts of a power system. That includes so many subtopics. What are those? Inductance or capacitance calculations, GMD, GMR calculations, performance analysis of short transmission line, medium transmission line, long transmission lines, underground cables, corona, insulators and string efficiency, like that. We also going to discuss the distribution part of a power system. So, switchgear and protection is there, that is very important. There we see design aspects of various types of circuit breakers, relays, their operation and also applications of relays, circuit breakers to important power system components like generators, transformers, transmission lines, bus bars. The over voltages produced in the system due to lightning, resonance, some other things also will be discussed. Advanced topics in power system like load flow studies, fault analysis, stability will be discussed in detail. The economic load dispatch, load frequency control, compensation techniques will also be discussed. HVDC transmission, the generation aspects, economics of power generation also will be discussed. As all of you know that this power system topic is very important in electrical engineering next to electrical machines. So, now I am going to give salient contents of this power system that we are going to discuss. So, in case of power system, first we will see the structure of power system and other related aspects of power system we discuss. Later we discuss transmission concepts. In that transmission concepts, so many subtopics are there. So, parameters of line, inductance and capacitance calculations along with geometric mean distance and geometric mean radius concepts. Electromagnetic interference, self and mutual flux linkages, and electromagnetic interference will be discussed. Transposition of lines, that also will be discussed. After that, performance of lines, we have a short line, medium line and long line. Performance of lines will be discussed. corona, that is unwanted thing in power system, that phenomenon, how it occurs, factors affecting, and some empirical formulas in that, methods to reduce corona are discussed. After that, we can discuss overhead insulators, and string efficiency. Different types of overhead insulators that we use for transmission will be discussed in detail here. Some numerical questions will be asked on string efficiency, those are also to be attempted. After that, we can discuss underground cables. This topic is also very important, where we discuss insulation resistance, electric stresses in various portions of a cable, dielectric losses occurring in the cable, capacitance equivalent circuit of underground cable, constructional details of underground cables, those things will also be discussed here. The line supports, various types of line supports are required in a transmission system, those things also will be covered. There is a sag, calculations are important, particularly this line supports and sag topic is required for students preparing for IES examination, but no question will come on line supports in case of GATE. After that, we can discuss distribution part of a power system. Distribution part of a power system, simply it is a distribution. Here we will see the different components of distribution. Distribution system, here we discuss the types of distribution systems, voltage and power loss calculations for different distributors, for different types of distributors will also be covered. Following this distribution, we can start switchgear and protection. Here we mainly cover different types of circuit breakers, their operating principles, applications also. Relays, different types of relays for different types of applications and as per their construction. Applications of relays to power system components like a transformer, transmission line, generators, bus bars, like that. Upon completion of this switchgear and protection, we can discuss load flow studies, that is also called power flow analysis. Here we discuss a load flow problem and its importance, admittance matrix formation, load flow equations, those are normally nonlinear equations. Solving load flow equations, using different methods. Gauss-Seidel method, Newton-Raphson method, and modification of Newton-Raphson methods may be decoupled method, fast decoupled method, or DC method. Once this load flows completed, we can start either fault analysis or stability. Either can be started, but before starting fault analysis or load flow, fault analysis and stability, load flows must be done. So, fault analysis, we are having symmetrical faults, unsymmetrical faults. So, in that symmetrical fault analysis, per phase or per unit representation is discussed. So, symmetrical fault analysis, unsymmetrical fault analysis. Unsymmetrical fault analysis is done by using a symmetrical components method. Symmetrical components method. After that, unsymmetrical fault analysis can be taken using this symmetrical components. Next, stability, power system stability topic can be covered. So, here two types of stabilities are there: steady state stability, transient stability. So, in the study of transient stability, equal area criterion is very important, that is also covered. EAC, equal area criterion. So, once fault analysis stability topics are completed, we can start economic load dispatch, that is also called economic operation of a power system. Here the economic load dispatch problem is defined first. So, those that is splitted into two parts, considering losses, without considering losses. So, here ELD, economic load dispatch problem is defined. Economic load dispatch problem using losses not considered, ELD considering losses. Two cases are there. Here loss coefficients will come, penalty factors also will come. Following this economic load dispatch, voltage control topic can be started. Voltage control, here it is we mainly discuss compensation techniques, series compensation, shunt compensation, load compensation, line compensation, like that. Here series and shunt compensations can be discussed. Power factor improvement is to be covered. After this voltage control, we can have transients in power system. Transients in power system. Here different types of transients are to be discussed. So, what is a surge? What is a surge? Its a specification. Different traveling waves, reflected, transmitted, incident waves are to be discussed. Reflection coefficient, so transmitted coefficient, those things are to be discussed here. Bewley diagram for representing these reflected, transmitted, incident waves at different instance of times at different points along the line can be discussed. So, once this transients is over, we can discuss load frequency control. Load frequency control. In this load frequency control, we can calculate area control error for isolated system, also for two area or interconnected system. So, here also we develop a model for load frequency control. We have regulation of generators. Using that we can calculate loads shared by the generators. So, integral controller used in this load frequency control are to be covered. Following this one, we can discuss a very important one, HVDC transmission. HVDC transmission. Here there are many benefits with DC when compared with AC for transmission. So, HVDC merits are discussed when compared to HVAC for transmission. And different types of HVDCs will be discussed: monopolar, bipolar, homopolar, back to back. These type of HVDCs will be discussed. Various components of HVDC system will be discussed. Power flow analysis, applications, everything will be discussed here. Once HVDC transmission is over, we can discuss a generation of a power system and economics of power generation. Here in case of generation, we will see about various sources of energy, conventional, non-conventional. Various sources of energy. Later, we can discuss in detail about thermal power station, that is a coal fired power station, hydro power station, nuclear power station. After that, we will discuss a combined operation of a power system and economics. So, this is the overall topic to be covered here. Here, this generation and economics topic is especially required for students preparing for IAS examination. For a GATE examination, even though generation topic is specified in the syllabus. No question generally comes in GATE examination. This is especially for students preparing for ESC examination. So, this is a very broad subject. It has many salient subtopics to cover in power system.